Okay, a manufacturer of colored candies states that 13% are brown, 14% are yellow, 13% red, 24% are blue, 20% are orange, and 16% are green. I wonder what those colored candies could be. A student randomly selects a bag of colored candies. He counted the number of candies of each color and obtained the results shown in this table. Let's open the table and let's throw that into StatCrunch because we're going to need it in StatCrunch. So we have proportions versus what we actually observed. So when we're doing a chi-square test, we can either put in expected frequencies or expected relative frequencies, expected proportions. So the null hypothesis would be that the manufacturer's claims are accurate. The alternative is that they're not accurate, okay? So the status quo, the less interesting, is the null. The distribution of colors is the same as stated by the manufacturer is the null, and the alternative is that it's not the same. Okay? So what is the expected count? Let's do under stat menu, we can do our goodness of fit test, a chi-square test. We're going to say what we observed in the frequency, what was expected in the claimed proportion. It's going to bring that all the way up to expected frequencies, and that's what we're going to have here. We're going to copy this. We have, what, 2 decimal places, so this is perfect. 51.87. We have 55.86 for the second color. We have 51.87, 95.76, 79.8, and finally 63.84. All right, great. Those are expected counts, the chi-square test statistic. It's given right there in our output. It's 16.141. P-value is also given, and we have 3 decimal places, but that would round it up to 0.007. 0.007. Tiny p-value means we reject the null hypothesis. Reject the null hypothesis. Let's see. There is sufficient evidence that the distribution of colors is not the same as the manufacturer. Oh boy. Something fishy going on at the colored candy factory.